All right, so today we're going over data structures part two. So last week we had covered conditionals and data structures part one, where we talked mostly about sets for our data structure. We're going to be reviewing various types of data structures over the next couple weeks. So there won't be any new logic concepts that you'll have to learn. You'll just be learning about different ways to structure data, basically, throughout the next couple weeks. So hopefully that'll give some time to better familiarize yourself with Python syntax and things like conditionals as we just learn more about structuring our data. Cool. So just to review what a data structure is essentially a means for storing and organizing a collection of data values. It's generally composed of primitive data types. Remember that our primitive data types are what we learned about in week 2 of the class, and these are strings, booleans, and numeric data types, but they can also include other data structures nested within them. And recall last week when we had reviewed conditionals, we talked about how you can nest conditionals within each other. With many data structures, you can do the same thing. Not all data structures, but many you can. You can try it with all of them, and you'll get an error if it's something that's not supported. But in many cases, you can nest a data structure within another data structure. Each data structure has their own set of methods or a defined action that can be performed on the data structure. Methods are called on a data structure using dot notation, as we saw last week when we did the set data structure, and we were calling methods like add and remove on those sets. So that basically looks like your data structure. So imagine we had a data structure stored in this variable called data underscore structure. And then we call the method with the parentheses after. Remember that any method requires the parentheses after it. Otherwise, it's just an attribute or a property of that data structure if you don't include the parentheses. And then you use the dot notation to call that method on your data structure. So it would be data structure dot method and the parentheses after. So there are many different kinds of data structures, each with their own relative benefits and uses. We've already talked about sets, but there are also tuples, arrays and lists, dictionaries, and objects. And then there are other types of data structures as well. So also, if there are any questions throughout, please post them in the chat. I feel like that's been working really well for our lecture so far. So yeah, any questions, please throw them in the chat and I'll answer them at the end of each slide. All right, so first today we're gonna talk about arrays. So arrays are an ordered collection of non-unique values that are all of a specified type, and they are mutable. So ordered. The elements within an array have a defined order, so the order in which you enter them is the order in which they will remain. So in this case, we're defining an array. We're specifying that it's an integer type using the I here, and then we pass in using these square brackets, like 3, 2, 1, 5, 7, 6, 8, 0, 9. And then when that's returned back, that order that I had entered up here is maintained in that array. Yeah. Keep in mind that with arrays, you're often not going to be using arrays themselves. We'll likely use lists instead of arrays, but it's just useful to know the small distinction between arrays and lists. Right, so they're also non-unique. Unlike a set, you can have multiple of the same values in an array. So remember with sets, when I entered in values like this, like 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4, 5, 5, 5, all that, it basically simplified it down to just the unique values in the set, because sets can only contain unique values. But with arrays, that's not the case. So we can have repeats of the same value. So if I repeat 1 4 times, we see 4 ones in the output resulting here. If we repeat 4 twos, we see that there. 3 threes, we see it here in the output. 2 fours, 2 fives, 1 6. So you can repeat values as much as you want in an array. So specified type. When creating an array, you must specify the type of the elements within the array, and all elements in the array must match that specified type. So as we've been seeing above here, the first argument to the array function is an I. It's the string I, and that's specifying that I want my values to be an integer data type. There are a number of other values that we can enter for this first string here. And if you're really interested in using arrays because you want to force a type inside of your inside of your basically list, you can look in the book that we've been using for this course, and that'll specify all of the possible values that you can use for the first argument here. Another thing to note is when you do that, you specify the data type as the first argument, and then a comma, and then the second argument is is basically your collection of elements that are going to compose the array, and those are wrapped in brackets, square brackets here. So the array function has parentheses after it. It accepts two arguments. The first one is the data type. The second one is the collection of elements that'll compose that array, and that collection of elements has the square brackets here. And finally, it's mutable. You can alter the values of the elements in an array relatively easily. So if I define my array, so my array set it equal to, using the assignment operator, an array of type integer with 321576809 as my collection of data elements. If I output my array, we'll notice that none of that order of values was maintained. And if I had any repeats, those repeats would have showed up here, but I just didn't happen to include any repeats in this array. And then we can change the values in there using array indexing. So when you index an array, and the same goes for a list when we get to lists, you use this bracket notation. So you call your array, so my array, and then you put this square bracket after it, and they are zero indexed. So that means that the first element in an array, its index is 0. The second element, its index will be 1. The third, its index is 2. The fourth, its index is 3. So that's how you can refer to the individual elements within an array. So here, what I'm saying is I want to take the item or the element at index 0 of my array and assign it the value 0. So then here, after I've done this here, I've said to replace the element at index 0 with the value 0, and remember, 0 indexing, that's telling it to replace the first element of my array. Now that I print out my array again, I see that the first element was replaced from a 3, and now it's a 0. And I could have done that with any element in this array. Say I wanted to replace the fifth element in the array, I would use index 4, because remember, 0 indexing. So if you want to replace the fifth element, you have to use index 4. Because the index is always like it's a number in the logical order -1. So I would say like my array square brackets, and I would enter a 4 there, and I'd replace it with, say, a 5. So now the value at index 4 would be 5. So we would say 0. This is index 0, index 1, index 2, index 3, index 4. So this would have been changed to a 5. You could do it for any of the indexes along the way here. All right, so looks like there are a couple questions in the chat. Hi, David, can you please give a reason why you would like to repeat items in an array? Yeah, so great question. There are just often times where it makes sense to repeat values in collections of data. So, say you're recording something like students' grades or something like that. It's very possible that if I'm recording values of students' grades in an array, it's very possible that 2 students get the same exact grade. I wouldn't want that to be overwritten or ignored, like in a set when I enter, say 2 students get a 95 on that assignment. I want that 95 to be recorded and maintained for both students. I don't want it to be just overwritten by using a set or something. Because if I use a set, then if I enter 2 95s into that set, then I know that, hey, some student or students in the class got a 95, but I don't know that all of them necessarily got that, or I don't know that there were 2 people in there that got a 95. All right, and then yeah, exactly. So it looks like Olivia had beaten me to it. Yeah, for students' marks, you would definitely want to use you would want to use like an array instead of a set in that particular case. And I see there was a direct message to me. I'm just gonna go ahead and read it to the class. Where can the Python workbook be found? So if you're talking about the textbook that we've been using for the course, I emailed that out after our week 1 lecture. There's also a link to it in our syllabus. So if you use the link in the syllabus, you can access the book there, or you can check your email from, I believe it was week 1 lecture. I had sent it as an attachment to our week 1 lecture. Recall that throughout this course, we have readings for every week. So you should be using that book to read before lecture. That will greatly help with your understanding of all of the contents that we've been going over. And I highly recommend, as you read through the contents in the book, it'll give you sample code as you go along. Code along with that. Have your Python REPL environment open like I have here, and code along with what they have in the book. It'll help you understand syntax and things like that, and it's just a great way to practice. That's what I always did when I was learning how to code. I would always, have my book open, and then I'd have my REPL environment open, and I'd be coding along with it. So highly recommend doing that.
Oh,
Hi.
hi.
Do you have a question?
No, I just came in.
Oh, okay. Sounds good. All right, so I don't see any other questions posted to the chat, but yeah, keep the questions coming in the chat. I think it's awesome, that one student asked a question in the chat and another student was able to answer basically with the same example that I ended up using. This is awesome. So keep it up. If you feel you can answer someone else's question in the chat, please do. I love seeing that. It's great to see that students are learning and they're able to answer the questions just as effectively as I would be able to. So that's awesome. All right, so on to the next slide. So arrays continued. So arrays aren't a built-in function. And if you're not talking, please go on mute. It results in some background noise. And if you have questions, please post them to the chat. Cool. So arrays are not built into Python. So far sets were built into Python. You didn't need to do any special imports or anything like that to use them. But with arrays, they aren't built in. So they need to be imported into your file. We'll talk more about packages later in the course, but you can do that using this syntax here. So we would do from array import star. The array package is automatically installed onto your system. It's just not built into the Python REPL environment. So you should be able to execute this line of code without issue. Again, you're not really going to be using arrays in most cases, so don't worry too much about it. But just know that if you're going to use an array, you have to do this syntax to use them within your code. So accessing individual elements of an array can be accessed via their index value. Arrays are 0 indexed, meaning that the first element has index value 0, the second has index value 1, etc. So if I define my array as an array of integer types where I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in it, if I remember with 0 indexing, that means that the first element in my array, so this is basically, I'm numbering them in the order that they are in the array, right? So this is the first position, the second position, the third position, but that's not their index value. Their position and index value are different. Their position value or their index value would be like the position value minus 1. So if I want to get the first element in my array, I use my indexing with these square brackets again, which we saw on the previous slide, and I would add in 0 and get the value at index 0. That value at index 0 is 1. And then if I do my array at index 1, that value is 2. So that's referring to this value here. So just remember 0 indexing. I know it's a really weird thing to wrap your head around, but you'll get used to it. Trust me. It does become natural with time. And that's a huge difference for those of you that know R. R is not a 0 indexed language. Python is. Most programming languages are often 0 indexed. R is an exception there. So then you can use this concept of indexing to replace the value of an element with another value. So as we saw in the previous slide, where I did my array at index 0 equals 0. So I could do that here, my array at index 0. So let's go ahead back to that slide and just see that line of code. If I took this line of code, which I really should have kept in my screenshot, I apologize for that. But if I took this line of code here, my array at index 0 equals 0, and then applied it above here with this same array that I've defined up here. Now, when I print my array, I'll see that 0 has been replaced for that first index value. And note something I do want to call out when I say print. When I say print it out in this context, if you ever see these 3 green arrows here, this means I'm in the Python REPL environment. The Python REPL environment, all it really takes to output something to the console is to call that value. But if you're going to be trying to output something from a file, like in most of our assignments, you need to use the print function, otherwise nothing will output. So that's a key distinction to keep in mind whenever you're working in the REPL environment versus a Python file. Cool. So it looks like we have a question here in the chat. Why do we have my array 0 equals 0 when we have numbers? So I'm not certain I'm following the question there, but I'll try to answer. If you could clarify, that would be helpful while I do try to answer. But so first off, keep in mind that what you've posted in the chat, I know that not everybody can see it because it was directly sent to me. You have parentheses around your 0. You need to use these square brackets here. So I'm just going to go back to the slide showing that example. You need to use the square brackets, not parentheses. And the reason you need to use a number here is because it's the index values are numbers. You can't use anything but numbers for indexing your function or for indexing your array. You also need to assign it a numeric value because with my array, I've defined that my array is using integer values. So I need to use an integer here. If I try to add, or if I try to substitute in a string here or a Boolean value or something, we're going to get some errors in our code because arrays require that everything in your array are of a specific data type. So I hope that helps to clarify that question a little bit. But if I missed the mark there, please do clarify your question in the chat, and I'll do my best to circle back to it. All right, so at this time, I'm not seeing any other questions in the chat, but please keep them coming if you have them. All right, so array methods. So we can use append, where you pass in a value to append. This appends a specified element to the end of an array. So if I do my array dot append and I pass in 11 there, that'll append 11 to the end of my array. So remember with dot notation, so we have our data structure, which in this case is my array. And then our method name, which is append, we're calling that on my data structure using dot notation. So I have my my array dot the method name append, and then within the append, within the parentheses on append, I'm passing as an argument the value 11, and that means I want to append the value 11 to the end of my array. So now when I output my array, and keep in mind that this array is the same array that was in the previous slide. Now, when I output my array in the REPL environment, we'll see that it's array 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11 is now appended onto the end. So that's how you can use the append method if you want to add something to the end of your array. We could also use the pop method. Pop removes the last element from an array, so and it'll also return that value. So if I call my array and I call the pop method on my array, and then output my array again, I'll see that the 11 is no longer on that array. And just keep in mind, as I go down the slide here, I'm using the same array from above and throughout. So every modification I make here, I then am modifying that same array here. So when I do my array.pop, remember dot notation, so my data structure, my array, using dot notation, I'm calling the pop method on my array. Pop doesn't require any parameters, so it's just empty parentheses here, but those parentheses are still required. It's a very important thing to keep in mind that the parentheses are still required. So calling that pop method there, it removes the last element of the array and returns it. So the last element was 11, it returns it to me. So now I see the 11 output to the console here. And then when I print or output my array here, now I don't see 11 in my array anymore. It removed it from the array. It both returned it and removed it. So then the next method we can use is insert. Insert takes 2 arguments, a value and an index. That's what IDX stands for. It's an index value. So it inserts an element into the list at a specified index. So if I take my array and I call the insert method on my array using dot notation, and then in my parentheses here, I pass in 2 arguments, I want to pass in the value 1 at index 1. That means that I'm replacing value 1, the value 1 here with another 1. So I probably should have used a different example here. That's my bad. But if I wanted to, if I use this insert method, what it's doing is it's inserting a 1 at index 1. Basically, what it's doing is it's replacing the value at index 1 with 1. So this is actually pretty similar to just using the approach that we saw on previous slides. It's pretty similar to this approach here. It's just a different syntax. It's using a method instead of using the bracket notation for that insert or overwrite there. So remove. Remove accepts a value, and it removes the first occurrence of a specified element from an array. So remember that with arrays, we can repeat values. So since we can repeat values in our array, we need to keep in mind that the remove method only removes the first instance of that. So here I'm creating an array, or I'm overwriting my array, and I'm creating it with the values 1, 2, 3, 4, 3, 2, 1. So I have 2 1s, 2 2s, 2 3s, 1 4, and all that. But they, it from end to end basically. So 1 starts it and ends it. 2 is the second and the second to last element. 3 is the third and third to last element, and then there's just a 4 in the middle. So if I call the remove method on my array and I pass in the value 3, even though I have 2 3s in my array, it's only going to remove the first 3 from my array. So now when I output my array to the console here in my REPL environment, I'm only going to see 1 2 4 3 2 1. Notice it removed this 3, only the first 3 in the array. Because keep in mind, again, just to reiterate, you can repeat values in an array, and you can also and the order is maintained in the arrays. So unlike sets, you can have repeated values and order is maintained. So that's why it removes the first element there, the first element that matches the value that you passed. All right, and then we have index value, and it accepts an argument of a value. So it returns the index of the first occurrence of a value in the array. So we're going back up to this array up here. This was just another example. I should really switch the order of these. But so if I take my array up here and I then call my array I'm sorry, no, I am still using this array. Sorry for the confusion. Please ignore what I just said. So this is my array now. It has 1 2 4 3 2 1 here. And I'm calling the index method on my array using dot notation. So my array dot index, and I'm passing in to the parentheses as my argument the value 2. And basically what I'm asking here is what index is the value 2 at in my array, and that returns 1 because remember 0 indexing. So the 1 here has the 1 here is at index 0, the 2 is at index 1, so it returns index 1. Again, this returns the first occurrence of a value in an array. So even though I have 2 2s in my array here, I'm only getting the index of the first occurrence of the 2 in that array. So I get a 1 back. We ignore the fact that there's a second 2 in that array. All right, looks like we have a question in the chat. Do arrays only work with numbers? No, so you can use different data types. I'd defer to the book for the different ways that you can define different data types in an array. There's different characters that you can enter as the first argument to the array function here. I don't know all of them off the top of my head. I rarely actually use arrays here. I just wanted to go over them because oftentimes people will confuse arrays and lists. They'll call them the same things, even though they are not the same thing. Arrays and lists are not the same. We'll go over lists at a later time. But yeah, so check out the book. The required readings for this week will clarify how you can use different data types within an array. And the different characters that you would enter as the first argument to the array function when you're trying to define an array of a different type. Great question. Any other questions? Please keep throwing them in the chat. I think this works really well. But since I don't see any others for now, I'm going to move on to the next slide. All right, so the next data type we're going to go over are dictionaries. So a dictionary is an unordered collection of key value pairs where values are mutable, but keys are not. So it's an So it's unordered. Dictionaries have no particular order to them and thus can't be indexed like an array or list. Key value pairs. Items of a dictionary are stored in key value pairs. Each item must have a key and a value, and these are separated by a colon. So you might recall from last week that sets are defined using the squiggly bracket notation here. You do the same thing with dictionaries, but the key difference between a dictionary and a set is that dictionaries have these key value pairs. If you don't include the key value pairs with the colon separating the key and value, you're going to end up with a set. So keep that in mind. But here I have key value pairs. So I have key one, colon, value one. And then a comma to separate this first key value pair from the next key value pair, where I have key two, colon, value two. And these are strings. And then another comma to separate key three, colon, value three. So when I enter that, returned back into the console, because I'm using the REPL environment, is that dictionary that I entered. It happens to look like it maintained the order here, and it'll often appear that way, but just keep in mind there's no real defined order. Dictionaries are rather key value stores. They aren't ordered stores or anything like that. So dictionaries can be defined using curly brackets or the dict constructor. So remember, dict with the parentheses after. My dictionary equals the squiggly brackets here. Your dictionary equals the dict with parentheses here. So then my dictionary is equal to your dictionary, true. But my dictionary is your dictionary. Remember, going back to the identity operator here, false. The reason this is false is because they aren't the same exact value in memory. And we actually had an excellent question in on the YouTube video, in the comments of the YouTube video from last week. I strongly recommend everyone check out the question relating to the is operator and why it's useful and how you can identify the actual where the value is stored in memory. I thought that was a great question. It's kind of high level. Don't worry if you don't understand all of it. But I thought it was a great question, and it kind of helps to clarify the difference between equality and is. So another thing to call out here is, remember last week we were able to define a set by saying, like my set is equal to these squiggly brackets here. So this is why it's better in Python, and this is one of the zens of Python, as they say. It's part of PEP 8. You should be explicit rather than implicit. Here I'm being implicit and just using the squiggly brackets. That implicit nature of the squiggly brackets is actually problematic, because looking at this, no one can tell whether or not this is a set or a dictionary yet. There's no way to know until you add some more context there, like add a key value store or add individual elements into that construct there. But here, when I do the dict constructor, and remember these parentheses are required because dict is a function and it returns a dictionary, now it's very clear that this is a dictionary. Everybody can look at this and they know this is a dictionary, not a set. And then the same thing goes for sets, where you can use the set constructor with the parentheses after. So this is definitely the better way to define a dictionary, but you can certainly get away with defining it this way. Just be careful, because it might confuse people. And in that case, it might be helpful to include in the name of your variable that you're storing that dictionary in, or that value in, whether or not it's supposed to be a dictionary or a set. So here, the thing that calls out that it's a dictionary is because I named my variable my dictionary. So then we know that these squiggly brackets are intended to be a dictionary, not a set. So just one example of why it's very useful to be explicit using constructors instead of implicit using just the brackets notation. Great. So I don't see any new questions in the chat, so I'm gonna just keep moving along. Please post any other questions you might have in the chat. So dictionaries continued. Instead of indexing, values in a dictionary can be referenced using their keys. So if I create a dictionary called fav color dict, so that like favorite color dictionary, I'm assigning to my variable fav color dict, I'm assigning it a dictionary, and in that dictionary we can kind of look at it as this is calling out who the person is and their favorite color. So the key is the person's name. So first key, David. The value, remember, separated by colons, the value is blue. And then John, say his favorite color is red. Jane, her favorite color is blue. Jill, her favorite color is purple. Paul, his favorite color is green. So keep in mind here, like, we have the key value pairs. So we have key, colon, value, and then comma to separate the first key value pair from the second key value pair, and so on. We're always going to have commas to separate our key value pairs here. So now when I want to reference, when I want to know, say, I look at my favorite color dict and I want to know what's David's favorite color or whatever. We have favorite color dict David. So using this bracket notation again, just like we similarly to how we do with arrays for indexing, instead of an index value, we pass a key value here. So we'd have to pass in some sort of key that exists in this dictionary, and then it returns the value associated with that. Then that returns blue. So then, based off the name of the dictionary, we know that my favorite color is blue. But be careful, you'll get an error if you try to reference a non-existent key. So in this case, notice how the keys that we have are David, John, Jane, Jill, and Paul. We don't have a Jack in there. So if I try to get the value using the key Jack, I get an error here. It says a key error on Jack, because Jack does not exist in my dictionary. There's no key called Jack in my dictionary. So make sure that when you're referencing keys in a dictionary, that it actually exists in that dictionary. Otherwise, you're going to get an error here. So on to the next bullet here. Dictionaries can be nested such that values of some key or keys in your dictionary is itself a dictionary. So quick hint, this is going to be required for the assignment to nest dictionaries within each other. So say I want to create a dictionary of contacts that I have. So I have a contacts dict, and this just has one key value pair in it. So I have David as the key, and then as the value, it's another dictionary. Notice the squiggly brackets here defining this other dictionary. And say their contacts is phone, so phone number. And here's the phone number for this imaginary person, David. Obviously, it's not my phone number. You all would have that in the syllabus. An email address. An email address for this fictional character is david@gmail.com. And then the address, again, we're separating here with the comma, separating our key value pairs with the comma, an address. And then the colon, 1234 Somewhere Drive in Denver, Colorado, 80221. So the outermost dictionary here has a single key value pair in it, and that's David and the dictionary of the contacts for David. And then nested within, and then in that nested dictionary, that's the value for David. We have 3 key value pairs: the phone number, the email, and the address. So now if we want to reference, say we want to know David's phone number, we pass in David to these first square brackets here. And then that is going to return another dictionary, right? So now having contacts _ dict David, that's another dictionary. So since that's another dictionary, we can tack on another of these square brackets, and we pass in another key there. Here I want to get the phone number, so I put in the phone key there, and then that'll return 1719-555-2879. So that's one way that you can that's a way that you can reference values in a nested dictionary, is by kind of recursively or repeatedly doing the bracket notation with the keys as you drill down into your dictionary. So we would have to do the first key of David, and then the second key we want the phone number. So bracket notation, and then the key that we're looking for there. Great. You can also add new key value pairs to a dictionary. I've missed the 2. You can also add new key value pairs to a dictionary. So notice above how we had, favorite color dict Jack, where I was trying to get the Jack key, and Jack didn't exist, so I got a key error. If I want to add Jack to my dictionary now that I know Jack is not in there, I can do fav color dict, square brackets, Jack is the key, assign it the value pink. So now when I print out my favorite color dict, we'll see that Jack has been added to my dictionary. So the key Jack is added to my dictionary with the value pink. So that's how you can add values to a dictionary. Yeah. So looks like Looks like we have a question. Can you create your dictionary without bracket notations? So we can create, as mentioned on a previous slide, we can create a dictionary in two different ways. We can do the square brackets here or the dict notation here. Oftentimes, if you're just trying to create a placeholder dictionary that's going to be populated at later times, it's better to do the your dictionary equals dict here. But if you're going to just define your dictionary straight from the get-go, it's often easier to just use the squiggly bracket notation. The reason for that is that it's obvious at that point when you have key value pairs within that dictionary that it is a dictionary and not a set. But when you're creating an empty dictionary, if you use the squiggly bracket notation, it's not obvious whether or not that's a set or a dictionary. So it's often easier when you're populating with values immediately to use the bracket notation, but if you're creating an empty dictionary, it's better to do the dict constructor. There are other ways, though, that you can use the dict constructor to cast other data types to a dictionary. That's outside of the scope of this course right now, but if you read up on it on W3 Schools and just look for examples online and in our textbook, there are plenty of them. So if you do want to see other examples of that, I strongly recommend checking that out. But yeah, great question. Thanks for the question. Cool. I don't see any others in the chat, so I'm going to keep moving along. So dictionary methods. So we have the get method. So get requires key and it can optionally receive a default value. So this returns the value of the entered key if it exists. Otherwise, the default value entered is returned if present. If no default is given, then none is returned. So we haven't talked about none in the past, but none is another reserved another keyword that's reserved in Python. And basically what it is a non-existent value. It's none, it's nothing. So if you ever want to create a variable that has no value whatsoever, it has no data type, you can use none. So here I do my contacts dict.get David. So since the default argument isn't required in the get method, I'm just passing a key. Key is required. So I have contacts dict.get David that returns the entire dictionary that I had entered on the previous slide for my David contact. But then if I do contacts dict.get Jane and say I want it to return that Jane is not in contacts in the case that Jane isn't in the contacts, then I can pass a second default argument here and it'll just say Jane not in contacts. If I didn't include the second argument of a default value here, we would have just seen a blank returned here because none would have been returned and none is just nothing basically. So you would have just seen an empty value returned there. Because Jane doesn't exist in the dictionary, and that's why this default argument was returned in that particular case. So the keys method, keys returns a list of all the keys present in your dictionary. So if I call the keys method on my contacts dictionary using dot notation, I remember the parentheses after keys, even though it doesn't accept any arguments, the parentheses are still very important to include. We do contacts dict keys with the parentheses. That'll return a dict keys variable, and that returns a list basically of keys. And I only have one key in my dictionary, so it just returns David in that list there. But if I had more keys, we would have seen a longer list there. So values, values, the values method returns a list of all the values present in your dictionary. So like the keys method returns all the keys present in your dictionary, the values method returns all the values present in your dictionary. So again, calling contacts dict dot values, parentheses are important again, even though it doesn't accept any arguments. So remember the dot notation for using methods on our data structures. This returns a list of dict values. So dict values here, it's just that dictionary value that I have for the contacts in my dictionary. So this just returns one value. If I had multiple values in my dictionary, multiple key value pairs in my dictionary, we would see a comma and then another value over here, but I just don't. So this is what's returned here. And then items. Items returns a list of tuples. So see chapter 28 for tuples. We'll be reviewing them, I believe, next week. We'll talk about tuples, but it returns a list of tuples representing the key value pairs of your dictionary. So if I do context dict dot items, remember the parentheses again, very important. Then this returns a list of tuples. So the bracket here, the square bracket here is a list. We'll talk about lists next week. Then the parentheses are how you define a tuple. The first value in that tuple is my key, and that key is David. The second value in my tuple, and it's demarcated by the comma here, the second value in my tuple is the dictionary that I've assigned to the value of the key David in my dictionary. So just be aware of all of those different methods. Yeah, so let's see, it looks like there's a question in the chat. How do you know which methods accept arguments and which ones do not? So that's a great question. You'll often need to look at documentation to understand whether or not the particular method that you're trying to use, or function, when we get to functions, you'll often need to use documentation to understand whether or not those require arguments or have optional arguments. So yeah, check out W3 Schools. That's one way to look at documentation, especially for these base classes and base methods and things like that. So W3 Schools will tell you whether or not a method requires an argument or does not. And it'll also tell you whether or not they're optional or whatever the case may be. So highly recommend checking out W3 Schools for this type of stuff, and just reading up on documentation. If you ever have questions on this type of thing, you could just search in Google Python dictionaries documentation, and that'll return a number of different pages that talk about how to use dictionaries, their methods, and all that good stuff. So highly recommend W3 Schools as well as our book. If you haven't been reading the book, please do go read the book. Check out the syllabus. Remember, these are required readings. I try to cover as much as I can in the lectures here, but I can't cover everything in the time that we have together, and that's why we need supplemental material of the book. And coding along with the book is a great way to learn. So please do read the book if you haven't been already. Start checking the syllabus every week and read the required readings before that week. It'll help with your understanding of the materials greatly. Cool. I'm not seeing any other questions in the chat. If you do have any though, go ahead and post them into the chat, and I will get around to answering them as I'm able. Great. So additional resources. Arrays. This isn't actually from W3 Schools. So if you want to read more about them, you can go to dataflare.training. They have a blog post on the array module in Python, and it's pretty informative. We won't really be touching on arrays in this class. I just wanted to call it out because arrays are distinct from lists, and it helps to know that distinction. I often hear people, even still in my professional career, people that I know have been coding for many years, referring to arrays and lists as the same thing. In Python, they are not. Maybe in other languages they might be the same, but in Python they are absolutely not the same thing. So it's important to make that distinction and keep that in mind. It'll just help with conversations with people around data structures and such, to know which data structure you're referring to and the caveats of each. But dictionaries, there is a section on W3 Schools on dictionaries. So highly recommend checking this out. Some great supplementary material to read about dictionaries and better understand them. And then also on W3 Schools, we have dictionary exercises. These are a great way to get practice with dictionaries and see how dictionaries are structured, etc. So please do check these out. I know that these assignments are quite difficult, and they're meant to be. And programming itself is difficult. It's quite a challenge to learn how to code. The learning curve is extremely steep. So I know most everyone is struggling in the class. So if you're struggling, just know that you're not alone. Most everybody is struggling with these concepts, but please, please, please take in all of these additional resources that I'm providing you. They will help you. They will help you in your understanding. I'm presenting these in a way that I hope will be beneficial to all of you for your learning. But reading about it in a different way and interacting with it in an interactive way on W3 schools using their exercises only stands to benefit you. So please, please take some time to go through all of this information, and play around with the exercises there, and also read the textbook. I think all of that stuff will greatly benefit all of you in your learning about Python and the various topics that we're covering here. That this is the reason why I provide these supplementary materials. It's not, I know that I'm not covering everything perfectly here, but if you do take the time to review the textbook and the additional resources I provide, you'll benefit greatly, I promise. Awesome. So another question in the chat, what is the reason for not touching much on arrays? Aren't they very relevant in Python? So great question. Lists are actually much more relevant in Python than arrays. The reason for not touching much on arrays is because you really won't see them very much at all. The reason being is that lists are just a lot more flexible than arrays. They're a lot easier to code with, and they're built into Python. Whereas arrays aren't. You have to import the arrays package, or the array package into your program to use arrays. The reason we cover them is just, again, to make that distinction between arrays and lists, because there is a distinction between the two in Python. But that's why we go over them. But the reason we don't use them much is just because lists are often better to use than arrays. And we'll talk about lists next week. And just note that for the assignment this week, it's not going to require the use of arrays. We're going to be using dictionaries for the assignment this week. So really focus in your learning on dictionaries. Just keep in mind the concepts about arrays and whatnot, but really focus in your efforts on learning about dictionaries, especially if you have limited time. But yeah, great question. Any other questions, please keep throwing them in the chat. For now, I'm going to move on to reviewing the assignment for the week. All right, so the assignment this week, we are going to be creating a searchable address book. So your client wants you to build them a searchable address book program, which they can use to determine if they have contact information for someone, and if so, have the program list out all of the possible ways in which the person of interest could be contacted. This program should store an arbitrary collection of contacts. Build this out yourself with fake contacts, and please do use the examples that I've used in the lecture. Each contact should have one or more of the following contact details. And note the one or more. Each contact does not require all, but it should have at least one and potentially more. So they could have a home phone number, a mobile phone number, a work phone number, a personal email address, a work email address, a home address, and a work address. And just keep in mind, again, at least one. Each contact doesn't need to have all, but they should kind of vary, like in real life. Sometimes you have work contacts, so you have their work address and their work email and maybe their work phone, but you don't have the other information. But your friends, maybe you have their home phone and their mobile phone, if any of your friends still have a landline, and a personal email address, and you might have their home address. But then there are also people maybe that you have a pen pal, so all you have is their personal email address. You don't know anything about their phone number or where they live or where they work or anything like that. So kind of keep it like a real address book, just having at least one, if not more, of each of the values here for each contact that you have. The name of the individual user that the user wants to search for is another thing that the program should store. So again, these should be in variables. So you'll have like a contacts dictionary storing this information, and then just a name to search for variable that you would store the name that the user wants to search for. So when run, the program should do the following. First, determine if the entered name exists in the collection of contacts. Hint, the in operator and the in here, and I'm just going to bold this in the assignment, just because that's a good call out to have. The in operator is your friend here. So determine if the name exists in the collection of contacts. In the case that the contact does exist, sorry, in the case that the contact does exist, the program should output contact information found for, name of contact entered. So remember when I do these squiggly or these angled brackets here, what I mean there is, you're substituting a value there. I'll highlight that in yellow to indicate that you're substituting a value there. I don't want this actually printed to the console. I want this to be substituted with the value that the user is searching for. So in the case that the contact does exist, the program should output, again, hint, print here. Print is going to be very useful. Contact information found for, the name of the contact entered. The program should then output each of the contact details available for that user in the format. Name of contact entered can be reached via their contact detail name, for example, home phone number, at, and then the contact detail value. So I'm just going to go ahead and highlight all these in yellow, just to call out that anything in these angled brackets and highlighted in yellow, these should be replaced with a value. I don't want to see these actual angled brackets and what I have here output in your assignment. These should be replaced with values from your assignment. And in the case that the contact doesn't exist, the program should output no contact information found for, name of contact. Be sure to ask them for their contact details next time you see them. So another hint here, you're going to need to use some conditionals for this stuff here, for determining if the name entered exists in the collection of contacts, and then determining what you output there. Keep in mind that I want you to, while each contact should only requires one or more of these, make sure that your program can handle all of these. I want to be able to enter my own contact dictionary that might have home phone numbers, mobile phone numbers, work phone numbers, personal email addresses, work email addresses, home addresses, and work addresses. It could have all of these. Make sure your program can handle that in this part here where you're outputting, the contact detailed name, for example, home phone number, and the contact detailed value. Make sure it can handle all of these possible entries here. So for example, say my address book contains the following contacts: David, mobile phone number 12345678890, work phone number 09876543321, personal email address david@home-email.com, and home address 1234 somewhere drive Denver, Colorado 80221 USA. And then another contact for someone named Zofia. So say they have a work phone number of this number, and a work address of this address here. So now, if the name that I enter into the program is David, the program would output contact information found for David. David can be reached via their mobile phone number at this value, and then also David can be reached via their work phone number at. David can be reached via their personal email address at, and David can be reached via their home address at. So this is kind of what you're looking for as the output. Alternatively, if the name I enter into the program is Zofia, the program would output contact information found for Zofia. Zofia can be reached via their work phone number at. Zofia can be reached via their work address at. So note that I have, for David, I have mobile and work phone numbers and personal email address and home address, but I don't have any of their work details. So you don't see any of those work details printed for David, but since I do have that information for Zofia, I'm outputting that stuff here. But since I don't have, say like a mobile phone number for Zofia, I'm not outputting anything for mobile phone number. And then finally, if the name I enter into the program is Jonathan, the program would output no contact information found for Jonathan. Be sure to ask them for their contact details next time you see them. Cool. So any questions on the assignment? All right. So since there are no questions on the assignment, I'll just go ahead and we can practice. I can show some examples of what was learned. Oh, it looks like there is a question. Let me go back to the assignment details. In dict, does the number of details associated to each key need to be the same for all keys? Great question. No, it does not. So, here, notice how I have like four key value pairs basically for David and only 2 for Zofia. So it doesn't really, that's not a requirement. The number of details associated to each key needs to be the same for all keys. So, David has 4 key value pairs associated with him. Zofia has only 2 key value pairs associated with her. Yeah, so one thing that is required though is that if you have a key, it must have a value. So, if my key is David and then my value is this context dictionary, hint, hint, then David must have that context dictionary. And if I put in a mobile phone number key for David, that mobile phone number must have a value. And if I put in a work phone number for David, that must have a value. So in the case that I don't have a work phone number or I don't have a work address for David, I wouldn't include the work address key in David's nested dictionary there. So another hint: you're going to need to nest dictionaries to get this all to work. And please do refer to the slides for help with how that would be structured. So if any problem encountered, can we ask you for help? Yeah, absolutely. If you've been struggling with assignments so far and you haven't been asking me for help, please start asking me for help. I can't read minds, right? So I need to know that I need you to tell me that you're struggling. So please, if you do have any issues, please do let me know. I will do my best to help. And when you do ask any questions on any of this stuff, please make sure to email myself, Raj, and Gaurav, so that all of us can respond to your questions. That first off takes a load off of me, because then Raj and Gaurav can help, because I still do like work full time and all that stuff. So I am busy outside of this course. So I might be slow to respond, but if you email all 3 of us, that increases your chances of getting a faster response, and it also helps me out a lot, because then a response isn't only on me to get back to you. My teaching assistants can help out, which is what they're there for. So please do email all of us whenever you do have questions. Yeah, any other questions? All right. So if there are no other questions, we are basically out of time, and I do want to respect everybody's time. Let me see. I'm trying to think of. Oh, one thing I did want to show is what happens when you do when you create a dictionary, and then you try to do the get, and that key doesn't exist without a default value. So say I have my dict equals, and let's just do hello world. So my key is hello, my value is world. So if I do my dict.get hello, it's going to return world, because the value for the hello key is world. But if I do my dict.get world, so keep in mind that world is a value, not a key. So there's not going to be a key in there for world. That's going to return none, basically there. So this is what a none return value looks like. It's just a blank line, basically. So keep that in mind. That's what that looks like without the default value. One really useful thing for using get is that this didn't result in an error, right? But if I did my dict and then I use the bracket notation for trying to get the world key from my dictionary, I do get an error there. So keep that in mind. That's why get is really useful compared to using the bracket notation for referencing keys, because get won't raise an error. It'll either return a default value or just none. But with the bracket notation, that'll return an error if that key doesn't exist in there. So just a call out there. All right, let me see. Was there? Cool. Yeah. So just in the interest of time, we're going to call it there for today. Oh, there's a question here. Bottom line, whenever the yellow bubble appears, it means that something's wrong. I think what you might be referring to is something like, let me just create a variable. world. Oops. So there's not a yellow bubble here right now. Trying to remember how I can get that to show up. So the yellow bubble, like the bulb. Okay, yeah. Good question. Sorry, I totally read your I totally read your initial statement wrong. That is my bad. So that bulb, which actually it did just show up for a second, that bulb is actually a tip. So a yellow bulb is not necessarily an error, but a red bulb is an error. So if you see a red bulb show up, like was the case if I take where was I when I saw that? Yeah, so see this red bulb here, that means there's an error. Rename reference, ignore unresolved reference, mark all, and like that's an error when it shows a red bulb like that. And when it's underlined in red, that's another way that means something is wrong. If you see any red squiggles throughout your code, that means there's an issue. So like if I go back to my hello world here, so notice no red right now. If I take out this closing bracket, see how I have a little red squiggle right here? That means something's wrong. And it's trying to put that where something is wrong. The yellow bulb doesn't always mean that there's a problem. It's often just a tip. So here, if you hit the drop down, it'll give you some tip like convert single quoted string to double quoted string. That's just a tip there. So if I wanted, I could click that and convert it to the dict constructor where I do dict hello equals world. And that's just the reason it's recommending that is because explicit is better than implicit, all that good stuff. Let's see, another thing that it was recommending previously was, converting it to double quotes. So anyway, yellow bulb doesn't typically mean something's wrong. It often is just a tip. But if you see any underline in red or a red bulb, that does mean something is wrong. So this is like just giving me a tip as well. So convert single quoted string to double quoted string. That just converted it to double quotes. Notice how I had single quotes before. Now it, is asking me if I want to convert it back. All that good stuff. Yellow bulb is often just a tip, and you can click on the recommendations it has here, and it'll have drop downs. This is why IDEs are great. And PyCharm is really helpful. It'll give you tips on improving your code. Yeah, because why not improve your code as much as possible? They're often helpful, and they're often in line with what with PEP8, because PEP8 is the style guideline for Python. And then here we go. We can convert it back to literal form. I do see another question from a direct message asking if I've received someone's assignment. I have. There are a number of assignments that I haven't had a chance to evaluate for assignment 3. If you emailed it, I should have gotten it unless you sent the wrong email. I will be responding to you here soon with feedback or an evaluation of your assignment 3. So yeah, just keep in mind, I do like work full time on top of doing this course, and I also have like some contracting work and some tutoring work as well. So I will be slow to respond. I just have a lot going on, so patience is greatly appreciated, but I will get back to you as I am able. And if you do submit assignments, you'll get a faster response if you can send it to myself, Vraj, and Gaurav, because then all 3 of us can respond as we're able instead of just me. So yeah. All right. Any other questions that anyone wants to throw in the chat before we end it for today? All right. Well, I'm not seeing anything else show up in the chat, so let's call it for today. I will send out the slides and assignment details here soon. I will also upload the recording of today's lecture to YouTube, and I'll send out that link shortly as well. And I will then. Oh, one thing I did want to call out. So next week, I will not be in town for our lecture next weekend. I'm going to talk to Raj and Gaurav about how they want to handle that, whether it be one of them take over for lecture next week, or maybe it might just make sense for you all to view the lecture from last from the lecture from last term. And then maybe you'll still join at the same time. They'd have to, Raja Gaurav would have to send out a different link because they won't be able to use my Zoom link for it. But maybe it would make the most sense for them to just join at our normal time, and then any questions you might have, they can answer. But I'll talk to Raj and Gaurav, and I will be sending out a communication regarding how we're going to handle next week's lecture soon. But just keep in mind that I'm not going to be here next week, but hopefully Roger Gaurav will be able to cover for me. If not, we'll figure something out. So I'll be in touch. But yeah. All right. Thanks everyone. Have a great rest of your weekend and an awesome upcoming week. I will talk to you all via email over the next week, and I will see you in our lecture in 2 weeks. Yeah. Have a good one. Bye.